time to work on Ethereum smart contracts. And when I say Ethereum, it doesn't necessarily mean it's for the Ethereum blockchain. It means that we're working with an Ethereum standard ERC smart contract, which we can also mint and apply to other blockchains that are also running on the Ethereum blockchain, or in this case, they're layer 2, meaning that they also adopt the ERC standard. Okay, so in this video, what we're going to do, we're going to discuss high-level discussion of the ERC 721 smart contract, because we are developing a NFT mint portal. Anyone that wants to get an NFT from our collection will have to log in to a website and mint the NFT. So with that said, we have to discuss a few items. We have to discuss the contract interfaces. We have to discuss the contract attributes. And finally, we have to discuss the contract interface functions. There's 3 items. There's a lot more to cover on the smart contract. I want to make this video as short as possible and going straight to details so you have everything that you need to mint your smart contract. There's a lot. When I say a lot of functions, there's a lot of functions that you can still apply. We're just going to go in describing the ones that we need for this particular contract, but that doesn't mean that they are the only ones, okay? I just want to make clear. However, this will get you a fully functional smart contract, so then you can start selling NFTs. Okay, so let's go ahead and start building our first smart contract. Okay, so we got our first smart contract, and I decided to do a quick PowerPoint presentation, presentation, so that we can discuss what's all of the smart contract fuss about. So this is what a smart contract logically looks like. I decided to do this presentation so you can have an idea of what we're going to be working with. So basically, the smart contract, it's composed of interfaces, the attributes, and the functions, right? So we got functions inside a contract. We got the interfaces that we call once we mint the contract. We decided to import some contract interfaces, and what they do is they basically give us the option or the capability of doing certain actions on the contract. Let's say ownable means that I can set an owner of that contract, right? Enumerable, it means that I can list the amount of assets inside the contract. Receiver, it means that that contract can receive tokens deposited. So I can actually transfer tokens to the contract address. And this is a good use case for staking. So we know staking on the traditional ERC20, but also on the NFT side, we can also stake NFTs. So that's also a capability with the receiver interface on the ERC 721 contract. The same goes to ERC20 and ERC 1155. Transferable, it basically tells you that. So you can send from one wallet to another, from one address to another address. And those options, we have to turn them on the contract so they are enabled and valid, and the clients can use it. Anyone holding that particular token, remember, any time that someone has an NFT from that smart contract and they want to execute certain actions, that token is associated to the smart contract, which means that I am going to execute whichever action do I have available on the smart contract. So that's very important to understand. Once you mint the contract, that's it. You cannot add any other functions. So you got to make sure that once you build a contract, you list what you need to enable from an interface and functionality standpoint. Okay. So with that said, let's continue. So the contract has a name. Obviously, when you mint the smart contract, you got to place the name of that contract, and usually we just name it the project name, right? So let's say we have XYZ NFT launch or project. We mint that token, or we mint that contract using the project name. So let's say we want to label it net2dev. That's my YouTube channel. So net2dev. Okay, so we are labeling the contract to be net2dev, right? The attributes, collection name. each NFT belongs to a collection. So you usually grab when you usually buy an NFT, it's part of a collection, right? So you have a collection name. Inside that collection, basically, it's all the NFTs minted. The collection is basically a reference to the smart contract that is holding the NFTs themselves. When you mint, you export or you grab one of those NFTs out of the supply, but then the contract is still associated to the collection name. So basically, that's what it is. It's the name of the collection, but it's associated to the smart contract, right? Token symbol. Like ERC20 or cryptocurrencies, you have a symbol, right? So Ethereum is ETH. The Polygon is MATIC, M-A-T-I-C. The Binance token is BNB. And we got others, right? So any token will have a symbol. This is no different. Even though that it's an NFT, or in this case, it's a utility, it's an art, it's an asset, anything that is a non-fungible token will still have a symbol, right? So you still have to think about what symbol do we want to allocate to our NFT collection. In my case, what I'm going to do, I'm going to say the name will be net to def. That will be the collection name. Let me expand this a little bit. Okay, perfect. Token symbol, N2D. Net to def. Okay. BaseURI. Okay, so the BaseURI is basically the path to where the metadata of that NFT is located. Each NFT will have a set of properties. I'm going to have another video just working on the properties of the NFTs because that's an extended session. I don't want to cram it into one long video. I want to have separate videos for that. But the BaseURI is basically the location in which the token itself has a reference to where the token attributes are stored, or the metadata. What is the metadata file? It's a text JSON format, or in this case, if you don't understand what JSON is, it's basically a set of instructions. It's a set of text properties written based on the token attributes, right? So let's say we're minting an NFT of a superhero, and the superhero wears a hat. The hat is a property. And where is that property documented or associated? In the metadata. And the metadata is where you actually associate the property of that particular NFT. Okay, so that will be in the BaseURI. That points usually to a decentralized file server that hosts those files. In this case, IPFS. IPFS is it's a very well-known decentralized file blockchain in which most NFTs are usually stored. And this includes the metadata file as well as the picture. So let's say it's an art, there's a PNG file, there's a JPEG associated to that metadata or to that NFT. So we store that in decentralized storage because we want to make sure that the files are always available, right? So let's say, user A transfers the tokens to someone else, user A transfers to user B, the path to the file location will still be there because that cannot be changed by the buyer. It can only be updated by the owner of the smart contract. So I want you to make clear that no buyer, no seller, if someone decides to sell their NFT in a marketplace such as OpenSea, they're still gonna be able to change that BaseURI path because that's only updatable by the owner of the smart contract. So who's the owner? Whoever minted the smart contract initially on the blockchain. So whichever wallet was the one that was used to mint the smart contract, that's the owner of the smart contract, okay? And you can still transfer. So that's why we have one of the contract interfaces transferable. We want to make sure that we have that because with that, I can actually transfer ownership of that smart contract to someone else. Okay, so let's say you want to transfer ownership of the entire smart contract collection. You can just invoke the transferable function. Okay, so we got the BaseURI, basically an IPFS path, and you're going to see that. I'm going to discuss that in more in detail. what's the base URI, and how can we create a JSON file with all the metadata. We'll create the JSON file, we'll create a picture, we'll do a test NFT, test JPEG. We'll update the base URI. The extension is basically what format is that file, and usually you are going to create a JSON file. Okay, so this will be the base extension of that file, metadata file. The base URI, it's basically the IPFS path to the JSON file. So basically we got the URI, which is the IPFS path, and we got the JSON file, which is the extension of the metadata file itself. Okay, NFT cost 0. And this is our price in crypto. This case, if we're minting it on the Ethereum blockchain, well, it's going to be price in ETH. If we decided to mint in another blockchain and there's a de facto token, like the token by default, then we mint it in that token. But at the end, this is just the price. So in this case, let's say we're going to sell it for 0.5 ETH. So that will be our NFT cost. And by the way, let me go ahead so it's better for you. And I'm going to upload this file so you can have it as a reference on the links in the video below, okay? So what I'm going to do here, I am going to label this red so everyone knows that this is the information that we are going to be populating in the smart contract, okay? So we got IPFS path, we got the JSON extension. So this will be the metadata file .json. Okay, then we got the NFT cost. Max supply. What's the max supply? Max supply, it's the amount of NFTs in this smart contract. And you have to be very careful, because once you set the max supply, you're going to change that. That's it. If the smart contract only holds 1,000 NFTs, because that's how we minted the supply when we initially roll out the smart contract, you cannot change that value. So you got to make sure how many NFTs are you going to hold on the smart contract available for purchase, because you cannot change that amount after this is minted. Okay. So in this case, let's say we're minting 1,000. Just put a number, right? And max mint amount. This is basically, if you remember on the previous video when we worked on the dashboard, the max mint amount is the amount of tokens that I can allow to be minted on a single transaction. Why we want to set more than one token per transaction? Because that saves gas fees for the buyer, right? So let's say the buyer wants to buy multiple, they don't have to mint one at a time. They can mint up to X amount. And this is where we set that X amount. For this demonstration, I'm just going to say maximum amount will be 3. 5. It's 5 because that's the configuration that we have on the web, on the React.js dashboard. We just set the maximum to be 5. So let's put it 5. Okay. So we got 5, right? Now with this information, I can go ahead and mint the smart contract, right? And I told you the interface, this is the interface in the smart contract. It's basically what we gain by enabling those interfaces. So, and when I say interface, I mean the functions. The functions inside the interfaces, I can then mint, I can withdraw, I can transfer, and other items I can execute because I am calling the interfaces, right? And usually when you see an interface, it usually, for 721, I think it's IERC. So any interface, let me just write it here. IERC, you're going to see an I at the beginning. That's basically telling you that's an interface, okay? So an IERC, that will be the IERC interface of the smart contract. Anytime that you see an I, that's basically the interface. You call that, right? And then once you call that, then you can build a smart contract and add your attributes and call the functions. Why? Because you code it and you enable those interfaces. Now you can interact with them and you can create actions based upon what interfaces are you enabling on the smart contract, okay? Okay, so now the next thing I'm gonna do, I am going to grab this information and we're gonna open the smart contract. That will be a Solidity file and we're going to update this, okay? Once we see that, you can see that I'm just gonna build a predefined template. I already got a predefined template. We can go and start coding actions, but I'm gonna do that on another video, but I don't want this video to be too long, right? I want to just go into the details. The file will be available also in the link below this video. Okay, so let's go ahead and perform that. Okay, so this is basically a ERC 721 smart contract. Okay, so in this contract, you're gonna see everything populated from the interfaces all the way to the contract information as well. We're gonna be working with the contract information or the contract attributes because that's what we populated in our ERC 721 smart contract builder. We can call it that way. So let's go back to my Visual Studio Code, right? And as I told you previously, this is basically the entire interfaces. So those are all the interfaces inside the contract that I have already pre-populated, right? You can build this contract. There is a website called Open Zeppelin when you can build a contract. I will call it the skeleton of the contract. From there, you need to start coding your Solidity specific attributes, right? This is already pre-built. So when you open the smart contract, this is basically a single file. From there, we're just going to scroll all the way to the bottom. And we are going to focus ourselves in the section where it says contract and then the name. This is where we are going to update this information with the details that we populated in our presentation. Okay, so with that said, we got the BaseURI. Remember, that's the path in IPFS and where we're going to store the metadata file. The metadata file, something that I forgot to mention, the metadata file holds the picture path. So let's say we grab the picture file, either a JPEG or a PNG file. We upload that to IPFS. In the metadata file is where we specify the path to the actual picture. So that the smart contract will point to the metadata file. The metadata file will point to the picture. Okay, keep that in mind. Okay, so we said that the contract name was going to be net2dev. Okay, and you can see here that I'm calling enumerable and ownable. Those are what? Interfaces, or those are contract attributes that we can use to call functions. Okay, so let's continue. Net2dev, the base extension .json, that will be our metadata extension format. The cost, we said that it was going to be 0.05 Ethereum. Correct, 0.05 Ethereum. And max supply 1,000. And we said that the maximum mint amount, it's 5. Okay, so meaning that a user can mint up to 5 NFTs on a single transaction. The base URI, remember the base URI? That's the IPFS path, and IPFS has a SID path. So basically, that's the way that they identify their path in the IPFS protocol. Basically, this points to a storage location in IPFS in which at the end of the storage location, at the end of the URI, what's going to happen, the smart contract will append the token ID. So in this case, let's say we minted token number 1 or NFT number 1. Then it's going to append the base extension, which is JSON. When your wallet gets that NFT, it's going to look at this path and it's going to be able to find or get the JSON. It's going to be able to get the JSON metadata file. Once the wallet opens that JSON metadata file, it's going to see the path to the picture, and that's how the picture gets displayed on your wallet and also in marketplaces. The moment we mint the smart contract, if there is an Ethereum-based NFT marketplace and they have an interface to the blockchain, they can list your collection on their marketplace. That will be done automatically. You're going to see that live in action. We're going to test with one smart contract. Okay, so this smart contract, we're just going to finalize building it, and once we're done, we'll mint it, and then we'll go into OpenSea, which is a very common one, and see if we can see the smart contract. Okay, awesome. So yeah, that's basically it. All we have to do is basically this. We don't have to append this, by the way. This is me just showing you But the base URI just needs to have this format. That's it, nothing else. This format, done. Once you mint a token, the smart contract will append the token ID .json. So what it does, it basically grabs the token ID and then appends the base extension, which then it's appended to the base URI. The base URI is this. So at the end, it grabs that token ID .json and it's able to find that path in IPFS and boom, and you get access to the metadata. Okay. Now, once we're done with this, oh, by the way, one last thing, I got to label the collection name. So this is base name. This is NFT collection name. We can say net2def NFT collection. And this will be the exact name that it's going to be shown in the marketplace. By the way, you have to make sure this is the name you want to label your collection, okay? And token symbol, we said that it was N2D, okay? That's it, nothing else. Once you're done with all this, we're just gonna select all, we're gonna copy, and we're gonna go to a public IDE or a public editor for Solidity, which in this case is Remix. It's called remix.ethereum.org. I'm gonna leave the URL right below here. And the remix.ethereum.org, we can actually interact straight with the blockchain, okay? So what we have to do is grab the smart contract and mint it using Remix. And with Remix, I can actually mint it on the mainnet, meaning this is the production blockchain for Ethereum, or I can mint this on a testnet. If you're testing the smart contract for the first time, you want to make sure you test it. You mint it on a testnet, meaning that they're not going to charge you. You just need to have fake ETH for the minting gas fees, and then you can go ahead and mint the smart contract and test it. You can actually test it, and you can see the art reflected on the OpenSea marketplace because they allow you to verify or test your smart contract using a testnet. So you're going to see that. We're going to do it, okay? So I am going to end this video here. On the next video, we are creating our IPFS location. We are uploading a test JPEG file or a PNG file so we can create a test NFT, and we'll make the metadata, and then we'll mint the smart contract and we'll buy an NFT. Alrighty, so if that was it for the Ethereum smart contract overview. This is basically the smart contract. This is all we have to do to get the ERC-721 NFT smart contract built. On the next video, I am going to upload the metadata. I'm going to upload a couple of NFT pictures, and then we're going to mint the smart contract. All right. So if you like my content, don't forget to subscribe, hit the like button, and we'll see you in the next video. Thank you.